So let's look at this particular question. Now, we've kind of, I hate to say zoomed, but I think the way that our objectives are broken down, 7A, B, and C, all kind of go together, okay? So that's kind of why we did them all at once. This particular question is very specific to objective 7C, which says, is the point on the circle? So it's kind of a yes or no question, right? And we even went as far as to say whether it was inside the circle or outside the circle, if you remember that from before. Before we do the algebra to prove it, let's take a step back and look at just the equation and let's graph it. Because if you remember, well, if you don't remember, but 7A talks about looking at an equation and telling me what the radius is, what the center is. Can we do all of those things? So let's look at this equation. And by the way, somebody else also asked me, is this equation of a circle on the SOL formula sheet? It is. So you don't have to memorize it, okay? So I will give that to you on your quiz when you take a quiz on this as well. Fair enough? Yeah. Which, not that with the numbers, but with the H and the K and the R in there. Is that okay? So that formula, I'll give you that. You don't have to memorize it. Awesome. There's not many useful formulas on the geometry formula sheet. That's one of them, though. All right, so when we look here, look at the equation. Somebody tell me if I wanted to graph it, I need two things. Who remembers what the two things are? So you need x and y, which is the what of the circle? The middle, right? What's the middle point called? The center. So we need to find the center of the circle, and we also need to find what? The radius, right? So can you look at this particular equation and tell me the center? Remember, look at the equation, tell me what you think. Something about the signs being kind of off. Does it sound familiar? What do you think, Ahmed? +4, -3. Very good. Remember how the signs are going to be opposite of what you think. Remember that from last week, okay? How about the radius? Look at the equation. What's the radius? It is not 8. It is not 4. It's 2.2. What? It's 2 point something. How'd you get 2.8? Good. So we know that r squared is 8. Do you agree? That's what the formula tells me. To solve for r, I don't divide by 2. I take the square root, right? So if I take the square root, what is the square root of 8? 2.8. Is it 2.8? Okay. So it's about 2.8, roughly. A little bit less than 3. Do you agree? So if I wanted to graph this, we're going to have to estimate it because our radius is not an integer. So 2, -5. What quadrant is that in? So remember, this is quadrant 1, 2, 3, and 4. What quadrant is the point 2, -5? Fourth quadrant, right? So 2, -5 is +2, down 5. So here is the center of my circle. Who remembers how I continue to graph? What do I do with my radius? Go ahead. That's the center. Uh-huh. Oh, what am I doing? Yeah, thank you. I graphed the point, not the center, didn't I? Thank you, Ahmed. I'm graphing this point. Let's graph the center. Let's come back to that point. We got to graph the center. Thank you, Ahmed. 4, -3, right? 4, -3. That looks better. Don't you agree? Sorry about that. Okay, now what? From the center, I'm going to do what with the radius? Go out. What direction? Up, down, left, and right. Don't I do all of that? So about a little bit less than 3. Do you agree? So if I go, let me just draw it with, well, I'll do it this way. So I'm going to go up 1, 2, I'll go a little bit less than 3, a little bit less than 3, a little bit less than 3, and a little bit less than 3. And I'm literally just connecting. Better than what I've done in the past. Didn't quite hit the bottom, but you get the idea, right? All right, so now I've graphed my circle, and I want to say, is this point on it? Okay, so the point 2, -5, Well, it's hard to tell by the way I graphed it, but it's close, wouldn't you say? Because I probably needed to go out a little bit more. I mean, it's hard to tell. So the graph doesn't give us a clear answer because of the way I graphed it. Do you agree?
Yeah.
So what's the clear way? Are you okay? Oh, you're just yawning. Okay. I looked at your face. I was like, oh my gosh. How do I solve? What do you mean by solve? Plug. What's another word for plug in? Because an S. Substitute. Let's use our math language. So I'm going to substitute these numbers into my equation. Do you agree? Okay? And so that's what Hewlett did already. So tell me what I do with the 2. Not 2 minus 3, 2 minus 4, because this goes in with the x, correct? Okay, so I have 2 minus 4 quantity squared plus, good. And I'm going to square it, and I'm trying to see if it equals 8. Look, what do I do at this point? Yeah, I substituted it. Now what? What do you mean by solve?
You do the squares.
So what am I doing it on my calculator? Am I doing it in my head? Am I asking God? Am I like, what am I doing?
You can, if you were me, you could do it in your head, but sometimes you gotta use the calculator.
Okay, so if we were going to plug it into, whoa, what am I plugging into the calculator? The left, the right, both? You don't need to plug the right in because it's just 8.
Yeah.
So what do I plug into my calculator? Okay. That's what I'm asking you. Do you know what to plug into the calculator?
Yeah.
Tell me what I plug into the calculator. Claudina, you should write it down rather than laugh. Well, tell me what you plugged in, Sweet Pea.
Negative 2 minus 4 squared. Yeah, well, parentheses, of course.
There's no negative. It's just 2 minus 4, right?
2 minus 4.
Okay. So you're plugging all of this into the calculator, the left-hand side, right? Okay. And when you do that, so Claudina, open your calculator. Aura, open your calculator. Stephanie, open your calculator. Tess, open your calculator. Let's plug it in. Let's substitute. Let's plug it into the calculator. Type it in. I'm going to walk around. I want to see that it does, in fact, equal 8. I'm going to walk around. I'm looking for it on your calculators. I want to see it. You did it 3 times. It's beautiful. Still working? Okay. I want to see it typed in. Lovely. Can I see yours? Lovely. What you got for me, Derek? Turn it on. Look like that for me, honey. Good. You're not there yet. I want to see it. Good. Let me see. Good job. Nice. Okay. Great. So when you plug it in, you do in fact get 8 on the left-hand side, 8 on the right. They equal each other, which tells me what? Yes, it's on the circle. Would you agree?
Yes.
Awesome. Perfect. How do we feel? Remember this from last week? We did this before. All right. So let's talk a little bit about what we did in the library last week for a minute. Okay? We will probably later in the year. I think we will. Yes, Lovey? Yes. So let me ask a different question. What would inside the circle, so on your quiz that you have on this, we decided that we're not going to do inside and outside. I think I'm going to offer it as extra credit though, okay? So if it was going to be inside the circle, what kind of a number, I'm going to ask you one more time. Listen to my question first. If we were asking if this point was inside the circle, what kind of a number would I get when I type it into my calculator? It's not going to equal 8. It'd be smaller than 8. And it would be bigger than 8 if it was outside. Okay? All right. So that would be extra credit on your quiz. Mathematics. Math rules the world. All right. So what I'd like us to do is I want us to revisit for a few minutes some circle vocabulary. Okay? So we talked in the library about a couple of types of vocabulary. What are some things that we introduced in the library in terms of vocabulary? What words did we use? When it comes to circles, give me some circle words that you know. Diameter, circumference, area. Weren't these the main words? Weren't those the main words we talked about in the library? I think those are the main ones, right? There are a lot more kinds of vocabulary words that we need to talk about. And today, we're going to talk about something called a sector. So if you don't know the word, I'd write it down. Okay? We're going to talk about something called arc length. Well, first of all, what is an arc? And then arc length. Some other words that you might, that's really what we're going to focus on today. So you'll need to know all of these words prior to getting into the actual math behind it. So we're going to spend about 10 minutes doing kind of like a little sort activity with this. There are a bunch of other words in your activity that you'll come across, okay? You'll come across something called an inscribed angle. I'm just going to see what you know, okay? And we'll come back in a few minutes and we'll define them officially. This is going to be, the top is for today. The rest of it's just for plain old circle vocabulary. So inscribed, and you have something called a central angle. I'm trying to think of what else you might have. A chord. I'm trying to think of what other words you will have. Chord, diameter, radius, tangent. Now, this tangent is not TOA in a right triangle. It's the same word that has two totally different meanings. Completely different. I know, right? Welcome to the English language. It's messed up. Okay? This tangent is tangent to a circle, not tangent in a right triangle. It's not the function tangent, like sine, cosine, tangent function on your calculator. This is an actual thing. This is a segment that you touch as a circle in exactly one place. Totally different. All right, so let me pause the recording. I would like it if let me go ahead and just pause. And let's talk about some of these vocabulary words that maybe we didn't get the first time around. So when I talk about a chord, let me just go ahead and just draw a big picture where I have several things going through. All right. So I'm going to label all of these points, and you're going to tell me what they are. All right? So I want everyone to look at the board. Based on what we just did in terms of the vocabulary, which one, name a chord on my picture up here. So a chord is a line segment, so it's going to have two letters. And where are its endpoints? On the circle, somewhere on it. So would you agree that CG, very good, CG is a chord? Do you see where G is? It's over here, right? So isn't the segment CG a chord? The endpoints are on the circle. Good. How about a secant line? Think about what we looked in terms of what you just did with the vocabulary. What a secant line. By the way, I just gave you a hint. It's a line, so it has arrows at the end, and it passes all the way through the circle. So EF, very good. So EF is called a secant line. Good. How about a tangent line? Remember, not sine, cosine, tangent, not the function, but a tangent line. Well, it's H something. We've got to put another point. Let's call it HI. Would that be okay? You got to have 2 points to name a line. So HI. And where is the point of tangency? Ooh, that's a big word. Point of tangency would be where it touches the circle. What point is it? H. Okay? How about a radius and a diameter? Look at the picture. There isn't one on the picture. Do you agree? Why not? Nothing passes through the center, right? Got to pass through the center. So let's make one up. How's that? And let's put letters on it. So we have, where'd I end up? I, so we'll say J and K. So what's a radius? There's a couple of them now. AK would be a radius. Because doesn't a radius start at the center and go out to the outside? What's another radius? AJ. Okay, good. How about a diameter? JK. Very good. Or KJ, however you want to say it. How do we feel so far with the segments in a circle? These are all segments or lines. We also talked about angles in a circle. Do you agree? So I need to kind of think about some angles here. So let me add some. It's going to get a little messy. All right. So we had a couple of different angles that we talked about. We talked about what's called a central angle, and we'll finish up after lunch. All right. So again, those are the segments. I'm going to kind of draw a little line here so we can kind of know that above the line are all the segments or lines in a circle, and below it are going to be some angles. So thinking about your sorting activity, and by the way, I picked all those baggies up, so I appreciate that. Central angle, think about looking at the picture. When we talk about an angle, where does the vertex lie in a central angle? Which is what word do we use for the middle of a circle? The center, right? Central angle, the vertex is on the center. So look, it's kind of a little messy, but look at the picture and think about an angle in the picture where the center is the vertex. Remember, center is A, right? Jessica, I'm going to need you to put your phone away right now, okay? So could we maybe look at going up to J and going over to H? Would that be a central angle? Yeah, sure would. So how do I name that? How do I name that angle? HAJ would be one way to name it, sure. Or the other direction, right? But let's do your first one, HAJ. Notice it says angle, HAJ, right? All right, here's another one, an inscribed angle. So these are words that you may or may not know yet. So these are some words, if I were you, I'd make sure I know their definition. So a central angle has the center on the vertex. Where does an inscribed angle have its vertex? On the circle itself. So an inscribed angle is an angle in which the vertex is on the circle itself. So let me pick a different color. So we're looking at an angle where so isn't really this right there would be an angle that would be, could be the vertex. So if we go out, isn't this angle right here? I need to make a letter for that, don't I? I think I missed that one. So we'll call that L. How do I name that angle? Angle what? LBK, sure. And again, B is the middle point when you name them, also happens to be the vertex. So we'll talk more about the angles in the circle a little bit later, okay? What we are going to look at is parts inside the circle that are formed by what are called sectors, and also arc and arc lengths. And that's what we're going to spend the rest of class talking about it. So we probably need to talk about what an arc and a sector is. Okay? Let's start with an arc. Thinking about the definitions that you guys sorted, there's lots of arcs on here. So let's name one. Say it again. BH? Sure. BH is an arc. I agree with you. Notice the notation has a little arc across the top, right? That means arc BH. Now, arc BH, I'm going to pick a different color. Let's pick, I don't know, pink. BH is that arc right there. It's the part of the outside of the circle. What word did we use last week that talked about all the way around the outside of the circle? Outside of the circle. Circumference, right? Do you agree that BH is part of the circumference? Okay, and we're going to use that information in a minute. What about, let's go all the way to J. And it's important that I go all the way to J, because JAH is a central angle. Do you agree? So when I talk about a sector, it has to have a point where? On the center, okay? Has to. Are we okay with that? So this sector is what we have in terms of the pink. And there really isn't a whole lot of notation that's used for that. We just call it the sector, okay? So the sector is what I've shaded in pink. Are we okay with that? Now, the sector, or the piece of the circle, the part, what is it part of? What's the whole thing that it's a part of? Not the circumference like the arc was, but isn't it part of the area of the circle? Isn't the sector part of the inside? And that's what we're going to focus on today. So here is example 1. Okay? Sectors in a circle. Example 1. You need to write this down. This is part of our notes. So the vocabulary that you have, again, we will have a vocabulary quiz later on in the week. I can imagine that it's going to look much like this, where I'm going to have a picture and you're going to have to name things. Does everyone hear me? Later in the week, you're going to have a quiz with a kind of a complicated picture, much like you see here, and you'll have to name all these things. Good? And QC, you can go online, and I'll put these notes on there for you. You can just print them off at home. Okay? All right. Let's talk about sectors. So I've drawn an example of a sector for you, okay? And I've given you in red a couple of formulas that you need to know. The area formula of a circle and the circumference formula of a circle. The first thing we want to do is find the area of the sector, of the shaded region, okay? Now, you'll notice you need a couple of things. When we talked about the area of a circle, what did we need? What information do we need in order to be able to find the area of the whole circle? Look at the formula. We already know what pi is, it's just a number, but you need the radius. Do we have the radius in the picture? We do, don't we? So I don't want the area of the whole thing, I want area of part of it. Does that make sense? So when you talk about finding the area of the sector, this is kind of like the formula. It's whatever the fraction is, the part of the entire area. Are we okay with what I mean? Part of the whole area. So what number can we fill in right now from the picture? The 8, right? We know the radius is 8. So I'm going to put 8 squared times pi. And I just have to figure out what the part is. Does that make sense? It's part of the whole area. Well, What other piece of information is given to us in the problem? The 45 degrees. And I actually don't like the way where it's put on the picture. This is actually the 45. That's called an arc measure. It's the measure in degrees of the arc. Sometimes you'll have it written there. Sometimes that little 45 will be a central angle. They're actually the same. Are you okay with that? So the 45-degree angle, when it's a central angle, also, whoa, that was kind of crazy. Let me see if I can grab the 45. Nope, 45. Oh, let me just take it back. There we go. All right, so the 45 can either be on the outside part to describe the arc measure, or it can be an angle, an essential angle, okay? They both can be, they're the same thing. So what does that 45 have to do with it? Well, it's 45 degrees of, how many degrees are in an entire circle? Whole circle, 360. Do you agree with that? Half of the circle, or a semicircle, would be 180. Luke, write this down. So this 45 out of 360, go ahead and divide that on the calculator. 45 divided by 360. Tell me what you get. You're going to get a decimal. 45 divided by 360. So just hang tight for just a second. Look at the picture. Is it less than half? Yes. Yes. Is it less than a quarter? Yes. Yeah. Less than a quarter, isn't it? Let's think about what our reasonable answer, just 45 divided by 360 is all I want you to do right now. 180 divided by 360 should give you half the circle, don't you agree? 90 divided by 360 should give you what? 90 would give you a quarter of it, wouldn't it? 0.25? This gives you point what? 0.125. I think it's one. Let me see what you got. What's 45 divided by 360? 0.125. Go to math, and then go back to decimal. Fraction of decimal. Times pi times 8 squared. You can just type it all into your calculator now, can't you? Take whatever 0.125, multiply it. Let's use the pi key. I know we were in the library last week. We used 3.14. But you have the actual pi key. Do you know where it is on your calculator? It's second, the little caret. Find it. Make sure you know where it is. The little, it looks like a caret. That's what it's called. I don't know. I didn't make up the words. Kind of like, why is your shirt called a black shirt? Because that's the color it was named 1,000 years ago. I don't know. I don't know why it's called a caret, actually. What'd you get? 25.1? Okay. 0.13? Sure. Now, we do need to put units. It's an area, right? Area of a sector. So look at the units on the picture. Not just plain old inches. When we talk about the area, it's inches squared, right? Square inches. So we have inches squared. How do we feel? So what information do we need in order to find the area of a sector? You need two things. You need a radius and a degree measure, right? Whether it's on the arc measure or whether it's a central angle, either one is okay. How do we feel? Okay? So, area of a sector. The next question becomes, what's the length of the arc? Different question. Remember, area is this formula. Do you agree? Arc length is a different question. Length, what formula are we going to use this time? Remember, arc AB is just the length of that. It is not 45. 45 degrees is the arc measure. Arc length is if I actually took a piece of string and I put it here and like went around the circle and I stopped there, it'd be the length of that string. How'd you get that? No. Okay, so don't guess. Let's make sure. What formula are we going to use? We use the area formula here. What are we going to use over here? Because isn't it part of the circumference? So again, when we're talking about arc length, it's the part of 2 pi r. Well, Hank, you guys, y'all yelling out numbers. Let's wait. Let's get there. Okay? So my question is, we'll come back to the part. What number do I plug in for r?
8.
Good. And then what goes over here again?
2.
No. The same thing we did over here. It's 45 divided by 360. It's just the part of, remember this is the part of the circle that we're talking about. It's the fractional portion of the circle, the part over the whole, and then of whatever the whole circumference is. Okay. I didn't do it ahead of time, so I'm going to trust you. Let me look at how you plugged it in. That looks fine, yeah. So 6.3.
Yes.
So what are my units here? Luke, well, come back to me. Dazen. So with area, we had square inches. Corbina, what is our unit going to be over here? You don't need to calculate. You just need to tell me the units. We already know the answer is 6.3. Is it inches, inches square? Is it centimeters? Is it yards? Is it miles? Is it, I don't know, what is it? It's plain old inches, okay? Plain old inches. When we're talking about area, we have square inches, all right? So arc length, we are using the portion of the circumference. Area of a sector, it's portion of the area of the whole circle. How do we feel so far? Not bad, right? It's something we kind of already know. It's just that portion that's different. Do you agree? All right, let's try another one. Here's example 2. Example 2. We're going to do one thing at a time. Let's just do, actually, let's do arc length first. Do you mind? Let's do the length of MC. Let's do the right-hand side first. So draw your picture. This is an important question. It's been on a released SOL before. You're going to see a question very much like this, similar to this when you take your quiz on this section. So this is a good problem to know how to do. So let's just find the arc length. We'll come back to the area in a few minutes. Arc length only. Got your picture? Notice what's actually shaded. Oh, I'm sorry. Is what shaded a sector? No. Why is it not a sector? Think about your definition. Where does the sector have to go all the way to?
The other side.
The center. So if I was going to call this a sector, wouldn't it have to be that whole thing? That's the sector, okay? But what we have here is part. We'll get to how to find the area in a few minutes. What formula, it's part of what? If we're looking at arc length. Stephanie, put your phone away. Part of what? Arc length is, look at your notes from the last example. Part of what? Is it area or circumference? Circumference. Arc length is circumference. Do I have a radius? Let me look at my problem. It said 5 centimeters in the problem. Don't you agree? Here is my radius. So we can plug in a 5. What goes goes on the other side? What's the part? Look at your degree measure. 90. Don't you agree that that's a 90-degree angle? So 90 over what? Very good. Excellent. All right, excellent. So type it into your calculator. Tell me what you get here. Make sure you realize the 5 is not that. The 5 is here. It's the unit. Okay? 7.8. What are my units? Centimeters. Plain old centimeters. Double check me. But it should be 7.8. How do we feel about arc length? Okay? Now, yeah, very good. When we talk about the area in this problem, it's a little bit different because it's not actually a sector. Okay? So we have to do something first. Before we get to the harder part, I want to make sure, are we okay with arc length? Any questions? Yeah. Is it 8.5? Yeah, let's make it 7.9 then. So we do want to round accurately. I agree. All right, let's talk then about how we can do the left-hand side. We want to find the area. Now again, it's not a sector yet, right? But what if we found the whole sector? What if we found, well, let's just do it this way. What's shaded in pink? It's a triangle. Can we find the area of that triangle? Can we find the area of the whole sector? What happens if we subtract those? What's left? The answer. What's in yellow? So if I take the area of the sector, which is the whole thing, right? The whole thing, and I subtract the area of the triangle, like I take it out, won't I have that little sliver of yellow left? That's what we're looking for. Okay? So we need to find two things. So let's find the area of the sector, and then we're going to subtract the area of the triangle. The sector is the whole slice of pizza, if you want to think about it from that perspective. Okay, I know, right? The whole slice of pizza. And I'm just going to take out the pink triangle because I want to find the area of the yellow shaded region. So, area of the sector. Area. It's part of pi r squared, right? Pi r squared is the area. What's the radius here? The radius is 5. And then what is my fraction for the part? What degree over 360? Good. And you can find that number. Ahmed, make sure you're paying attention, sweet pea, because this is going to be on your practices. You're going to do it in a few minutes. And a problem just like it will also be on your quiz. Very important. So go ahead and find that number. Tell me what it is. Plug it into your calculator. Plug the numbers in. We're going to find the area of the triangle in a minute. We have to subtract that off. What's the area of the whole piece of pie? The whole... 18 or 19? 19.6. Did you get 18? 19.6. Okay. Now I have to subtract off something, don't I? What am I subtracting off? The area of the triangle, right? I'm taking out the pink triangle. What's the formula for the area of a triangle? 1/2 base times height. Do you agree? Area of a triangle formula is simply 1/2 base times height. Look at this triangle. Look at the pink triangle. That's what we're trying to find the area of. What's the base of the triangle? 5. What's the height of the triangle? They're both 5. Isn't the base and the height radiuses? They're all 5. Not everything, but the radii, the height, and the base are all 5. Radii is plural for radius. What'd you get? All right, so 19.6 minus 12.5. And that's an exact answer, right? 12.5. Subtract them. We want just the yellow region. It is 7.1. Shh. And what are my units? Not just centimeters. Don't yell it out anymore. Square centimeters. Very good. Okay? So again, arc length is part of the circumference. Area of the sector is part of the area. And then sometimes we have to subtract off other things to get the little piece of the shaded region that we want. It is a lot of work, but I believe in you. I know you can do it. Okay? So let's practice some of these.